Hi there. Let's look at benzene reactions. The first one, how to produce benzene. So what we can do, we can take acetylene or ethine molecules, and under strong conditions, harsh conditions, high pressure, high temperature, these three of these molecules, ethine molecules, can combine and give you a benzene. So that's one way to make. So another easier method would be taking benzoic acid and remove a carbon dioxide molecule from it. So the benzoic acid, you can clearly see there is a CO2, right? And how do we remove it? We take calcium oxide, sodium hydroxide, heat it, and then that will remove a CO2 here. So try to notice that way, so you know removal of CO2 will, or decarboxylation will, give you a benzene. So what's the other method? You can also use phenol. So the phenol, you have to remove a hydroxide group, right? Hydroxyl group. So how do we do that? We react with zinc powder, and it's a reduction. Okay, so that will give you benzene. So another method is actually you can make benzene out of diazonium salts, and that's a really a good laboratory method. So diazonium is diaza, N2 plus and Cl minus, and if you treat with phosphoric acid, so you're going to get benzene. So it's a diaza reduction, and then you'll get benzene. Now the reactions, the common reactions are, there are a few. First one is I would take, well, benzene typically stable, but we can make some reactions happening, right? So the first one we should look at is nitration. So the nitration is you have to make or add a nitrate group, NO2 group, into the benzene. You need to have a nitration reagents, that's sulfuric to nitric 1 to 3. So that mixture will give you NO2 plus, and that will attach to the benzene nucleus, right? So that's nitrobenzene, and then you can go further. And the other method is attaching an alkyl group to benzene. So that's the aluminum chloride, and that's anhydrous aluminum chloride. It's called the Friedel-Crafts alkylation, and you're going to get alkyl benzenes, right? So that's a Friedel-Crafts alkylation. So that's a popular method, good laboratory method. Now what's the other reactions? You can actually add a halide into the benzene nucleus. That in adding halides, you need to have a Lewis acid as a catalyst. So what we need is FeCl3, aluminum chloride, something like that. So iron also would work, but iron actually will turn into iron chloride first, right? Okay. What's the other reactions we have? We can also get acyl attached to the benzene ring. So that's basically still the Friedel-Crafts reaction, but in this case you're using acyl chlorides. So the acyl chlorides production also, and just similar to the alkylation of benzene, and that'll give you that. Now also you can produce cyclohexane in the presence of hydrogen and ranitol. And that one, I think we talked about that in the other video about stability of benzene and the hydrogenation enthalpy. So that's a really important one to understand, and you can watch perhaps that video for that. Now, now let's look at few other reactions. In phenol. So now I'm just jumping from benzene to phenol, because phenol also similar reaction, but it's much more reactive. And so in phenol, why it's more reactive? Because it's a weak acid actually, phenol. So the electron lone pairs on the oxygen can donate into the benzene ring, so it's enriching the electron density of the benzene ring. So therefore it's more reactive and it's electron rich, and it's more active than benzene because benzene is our baseline, right? Okay, so the first reaction we can take is we can react with let's say under acidic conditions. What happens? Yes, so before we go to that, actually we should look at the benzene is the comparison, like I said, and then phenol would show ortho and para reactivity directions or directives, ortho-para directives or ortho-para directions, or benzene nucleus will be more active than the benzene. So that's what I want to show you here. Okay, now how do we get phenol? You can actually start with diazonium chloride, like I said, because diazonium chloride or diazonium salts are versatile. You can get phenol by reacting with just a hydrolysis of diazonium salt. Now, what's the other reaction? Well, actually, how do we get the diazonium? So that's another question then. So we can start with aniline, and that one reacts with HNO2. The HNO2 is not there actually. What do we do? Sodium nitrite and HCl will produce HNO2 in situ, and then that will give you diazonium salt, and then you react with acidic conditions and it will give you phenol. So another method to get phenol is benzene sulfonic, and you warm with sodium hydroxide and then you remove the sulfur trioxide, sulfur dioxide, and then you get the sulfur dioxide actually, so then you get the phenol. Another reaction is again, so it's a diacer compound with the sulfate instead, and this derivative also you can warm and remove the sulfur portion, sorry, nitrogen gas actually, and then you will end up with phenol. So most of these diazonium salts will remove nitrogen gas. That's the driving force there. Now let's look at few important reactions. So the phenol will react with sodium metal and removing hydrogen gas and making the salt of the phenol. And it's pretty stable. You can draw the resonance structures on it. So similarly, it can react with sodium hydroxide. Again, it's going to get the phenate ion. So just make sure, try to practice phenate ion, the structures. And resonance structures, there should be 3 to 4 structures can be drawn, right? Now, what's the other reaction you could do? You can do a nitration easily. And so because phenol is more reactive than benzene, it's easily you can add more than one nitronium group. So you would add 2 ortho and 1 para. So that means trinitro compound you can get from the phenol, right? So you're gonna add, because those are the places will be more reactive, 2 ortho and 1 para, which is 2 and 4 and 5 positions of the benzene when it is labeled as OH as number 1. Okay, now let's see the last one. That's the reaction with sulfuric. So the sulfuric reaction on phenol will give you a para compound, which is sulfonic group, and that one should be para position because phenol already taking place the number 1 position, and the number 4 position is far away, so that would produce the parasulfonate group for the derivative, right? So it's very rare going to have a ortho derivatives, or 2 and 5 derivatives are rare. Thank you.